So as I mentioned previously, when you use the integral test, it only tells whether a series converges or diverges. It doesn't actually give the exact value of a convergent series. So once you apply the integral test and you find that a given series converges, what we can do instead of getting the exact value is to estimate the value. So the way we estimate the value is by computing a partial sum. As you add the first n terms of the series, and if you take n large enough, you get most of the value of the series. And then once we compute this estimate, we can find how much we're off from the actual value, so the area of this estimate, by computing the remainder. And so the remainder of the series is given by this inequality. So the remainder is less than or equal to the tail end of the integral. So the tail end is when you integrate from n to infinity of f of x dx. Right. So for large values of n, the estimate is going to be better, and the tail part of the integral is going to be smaller, and so the error is going to be smaller. Okay, so let's look at an example. So we've seen that the series 1 over k squared converges. Right, so this is a p-series with p equals 2. So we know that it converges, but we don't know the actual value. So suppose we want to know how many terms to add together so that our estimate is within an error of 3 decimal places. So we use this inequality to calculate the error. So the error, Rn, is less than the integral from n to infinity. So the function in this case would be 1 over x squared dx. So the antiderivative is again minus 1 over x from n to infinity. As x goes to infinity, this goes to 0. And then at n, this is minus 1 over n. So the improper integral is equal to 1 over n. And we want the error to be smaller than 0.001. So now, to know how many terms to add up, we find n so that 1 over n is less than 0.001. So if you solve the inequality, you get n is greater than or equal to 1,000. So this means that if you add the first 1,000 terms, of the series, so 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, and so on. So you add the first 1,000 of this. This estimate will be within 3 decimal places of the actual value. So you can use this formula to estimate the error of a partial sum.